Welcome everybody back to JetShop VR Studio with a special episode today. Today I'm going to present to you the electrical diagram for the FPV planes that I fly mostly here. Aircraft I use INAV, a flight controller, and I have that hooked up through Crossfire. So I'm going to show you how I hook that all up and how it goes into these aircraft and how you want to be thinking about doing all the wiring as you're going through the installation. I've been getting a lot of these questions over various years. As I fly, people want to know how to get the pan tilt set up, the FPV, people want to know how to get the telemetry through the goggles, so I feel like this is going to be the most simple yet straightforward way that I can explain how to do this. Please download this diagram attached. This is I'm gonna walk through this diagram as I go through the next section and show you how everything is connected into the plane. If you have any questions about anything in this diagram or something that I'm missing or something you want to explain further, please comment down below your suggestions. I read all of them and would love to try to help as many people as I can. If you do stick around to the end, I do have some special content for you as we go through, so go ahead and make sure you're looking out for this special content. I hope that you can find some help from this video. What I would like to make notice to you is that the control signal goes from left to right and the video signal goes from right to left. So generally the flow for these diagrams is left to right. You have your inputs on the left and the outputs on the right. But when you combine the video signal in, the video is almost like an input to the camera. So the video goes into the camera, goes through this whole transmitter system to the goggles. This goes to your eyeballs. Your brain sees these from your eyes and makes a decision, and then this now makes you move your fingers to move the controls. This movement of the controls now sends the signal over to the plane to make it do whatever actions that you have deemed necessary based on what you saw in the goggles. So that's the whole control signal flow of the video and control links. When you're setting up an aircraft for the first time, or you're getting things, or you're trying to learn some new systems, you generally want to lay them out like this and get everything working and tested before you put them in an aircraft and things get complicated. When things are laid out like this, it's a lot easier to troubleshoot problems, replace cables, do a quick solder, or whatever have you to get things working. There's this diagram here that I printed out. I'm going to reference back to this with a marker, and then as we go through the components, I'll talk about them and how to install them, and then I'll put a checkbox, so if you're skipping around in the video, you can see where we left the checkbox and jump around. To this main part here, what I'm going to do now is I would like to focus purely on the flight controller first. There's a lot of components going on here, and this can be really daunting at first when we're getting into the electronics. So what I'm going to do is strip all of this off and just talk about the flight controller first, and then we're going to go ahead and expand from there. So we've got just the flight controller here, and we can see that this one is already soldered up here. I've done most of the soldering. I've done all of it. I'm not going to discuss that in this video. If you would like to see a video talking about how I solder these up quickly, please leave a comment below. But what I'll show you here is this is already pre-soldered. What I have is ESC 5 connectors on the battery, or EC5 connectors on the battery and ESC side. And then I've got a capacitor here, and the jumper cables that go between the Matek bottom part are kind of out to the side here. I've had a problem where these wires will short if this gets too hot, if these are inside. So this has been working for me. So here it is. Let me get a little bit closer look here at all the pins. So this is the Matek H73 Wing V3. This is probably one of the fastest and most reliable boards, I would say, in the price range. It has plenty of pins for, up to 12 channels, I believe. and then you've got all your pins over here for your sensors. So this board is plenty overkill for what we're gonna do. What I like about these boards is that they provide return to home function and telemetry when you're flying FPV. So this is going to be life-saving type functions when you're flying around and you may lose video and you need to return to home, or even the telemetry data is always extremely helpful when things are working. You want to know how fast you're going, what's your altitude, and you want that stuff on demand. So this is kind of the baseline here of what's going to provide that information to the goggles. So let's go ahead and get into how this starts to get connected to the rest of the system. I'm going to lay out the diagram here. So this thing really is kind of like the very center of this whole thing. If you think of this line here as the sensors, this is the controllers, and this is the outputs, then this is kind of, everything is kind of coming to into connection at this point. So this is really what we call the CPU, or the central processing unit right here. So this guy sits here, and then I'm going to pull him off to the side. And the first thing that we're going to do when you get one of these here and you have it all soldered up like this is it comes with a USB connector like this, and you can plug it in. And then once you got it plugged in, you want to go ahead and plug it into your computer through USB and start to do the INAV programming. Now, I am already on the latest INAV 7, and that's been working great. But what you want to do is go ahead and start to flash the firmware and start doing the calibration. Do your calibrations. It's going to ask you to flip the board like this, like this, like this, and do all these rotations. Do all of that before you even put this in the plane. That is going to save you a lot of headache. And ideally, you're going to do all of these steps we're going through before you even put your equipment in the plane. This is going to ensure the reliability and make sure that all your systems are functioning as expected. So once you have all, we're not going to go through the programming in this video. This video, I'm focused on this diagram here and the hardware associated with all the FPV gear. But if you need some help with the programming, again, please comment below what part you need help in. All of these parts require some specific programming, so if you have a specific question, please give a comment and we'll try to address your question. I imagine that this diagram will get simpler as we start to discuss this more, and that we will be able to help other people get involved in FPV a little bit easier. Once you have your flight controller programmed to INAV and you see that it's working and it's rotating right, generally the next thing you want to do is go ahead and get your receiver hooked up, whatever receiver that you're using. For this one, we're going to use the Crossfire Diversity. This is how I have it channeled up here. So if you look here, I got these pins to the top right. It goes black, red, yellow, white, and that goes, I've got this connected to like a 4-pin style connector. They call these 4-pin DuPont connectors. So what I do is I plug this one in very nicely to the very bottom right corner, and this slots in basically just perfectly. Let me see if we can get it connected. Yeah, there you go. So once you have your receiver up, we can kind of start moving on towards the next step. I want to talk about the GPS now. What we want to do is take a look at the label or the outputs of the GPS. So this is an M8Q GPS. It does really well. It collects satellites very quickly. And then there's an M10 version that's doing really well right now as well. So I've had never any problems with these with INAV. But again, take a look at the pinouts. It's 5-volt ground, RX, TX, DA, CL. And then that's going to be associated to the colors on the left. red, black, blue, white, green. So on the other side, you're gonna wanna clip this wire and solder your own 6-pin connector. What I've got is 2 3-pins, that'll work too. So first, I've got the black and white connected to black and white, and then you're gonna connect the blue to this extra white on this cable here. So that's your first one. And then your second one is gonna be black to yellow, red to green, and white to white. So that one makes this easy because white's always to white. And then that gives you these 2 here for 6 total. So let me stretch this out so that's very clear how this is
and let me be very
set
clear.
up. Kind of hard to see with the little shrink wrap there. But yep, just rewind and make sure that you've got all your cables set up here. So what we're gonna do is start with the black and red cable first, which is the ground and 5-volt. We're gonna plug that in right on top of the receiver, right on this far left side here. And then next, in the same orientation, black, red, white, tucked in right on top of it here, right next to it. So that gives us this type situation here. That's now plugged into TX RX2. Here's the receiver down there. Okay, so that's all plugged in now. When you have this plugged in, go ahead and go back into INAV through the USB and make sure that you've got, this is connected and the ports are set up, and this is now receiving some information to the flight controller. What you should see is the barometer and magnometer start to turn blue, and you get some GPS signals if this is set up in the settings. Another problem that you might have is if some of these systems are red, it shows it's connected, but it's somewhat red, is you want to make sure that you're not getting interference to the GPS through this cable here. So what you can do is wind this up a little bit and build a little bit of inherent interference protection, and then when you install it to the aircraft, make sure it's kind of separated from anything else, and that should help. We're going to put a check mark here on GPS. This is going to be the primary control functions here on the aircraft side. You can think of like an imaginary line here and here, where this side is the aircraft and this side is the ground station, and then up top is the video systems, and the bottom side is the control system. So we've mainly completed the control system for the aircraft. What we're going to do is kind of talk about how this connects to the controller next. Like with most RC planes, there's a remote that connects to a receiver, and that's the control link. That's also shown here. For my example, I've got the TBS Tango 2 with a module TBS Crossfire Lite attached to it. And so this is actually doing the transmitting in this case. And then this is my controller of choice. So what we're also doing here is we've got a Headtracker portion is also connected to this module here. So in this example, I have it kind of attached up to here and covered in some black weathering tape so it doesn't get hit by any water. Here's the USB here so you can see it. And the nice part about this comes with a Headtracker input that you can put a Headtracker cable into, and it comes with this. So what you need to do is just connect this to your Arduino, and this will allow you to receive the head tracking information from the goggles. So let's talk about that really quick. What we have here is the goggles, and I have the head tracking piece here. And so let's discuss what's going on there. This head tracking piece is glued to these goggles just like you saw, and there is a gyroscope on there just like the Wiimotes, and that kind of tells if the head is at pitched angle up, down, left, right, and what that does is it transmits that up, down, left, right information through the head tracker link to the Arduino that's on your remote, and what that's translating that is into pan and tilt channels. There is an open source software that I have linked below that works with these Arduinos. What you can want to do is program those Arduinos to do this head tracking function for you. It's open source, it's really easy to program. And then what it's going to do is send these head tracking channels through your remote, basically just as 2 channels. So if we go back here, we can see that this head tracking here, right, your gimbal is being passed through your remote all the way to the flight controller up to this 2-channel here pan tilt. So that's all it is, it's 2 channels. It's pretty simple. Now that we've had a quick discussion about how the remote is sending control signals across and this backpack and the head tracker links, I want to have a quick discussion about this Arduino on the head, on the goggles, and how that's actually set up here. So as you can see, I have got this barrel connector here attached to it. That's how this is going to receive power. Now, if you have the standard DJI battery that comes with the goggles, like this, it comes with this connector right here, with this cable. So you plug this cable in, and then this is what you plug into the goggles. So what there is available is this security barrel connectors that takes an input of that barrel connector and splits it into 2. And this is available on Amazon, and you get a 2-pack of these. And then just your battery here, I've got it here. You're gonna plug it in. Let's see. You're gonna plug it in here. So now you've got 2 outputs of this battery here going on. Okay, that's really nice. So then we're bringing the goggles. What you can do is now plug this into the goggles here on this one. And then this one gets plugged in here to your Arduino. And boom, you've got power to these 2 guys. And then this gets wrapped into your battery strap or what have you. So the question is how do you get this connector then?
That's a good question.
Now, when you buy these double barrel security connectors, they usually come in a 2-pack. What you want to do is you keep one for your goggles, keep the second one here and clip it here. And what you want to do is now solder this cable onto your Arduino, and this is kind of how you get this input here. This one again is covered in black tape for some weatherproofing. I'm also using the Sense version here, so it centers the aircraft. All you have to do is just kind of put your hand in front of it and it centers it. So this is a really nice function to have. So yeah, this is basically just how I have it glued down. If you're interested, I just brute forced it with hot glue. I've also done this many times, so it's slightly elegant but not super ugly. But yeah, I quite don't mind it. Now that we've covered the ground station briefly, I want to get back to the aircraft and talk about how we connect up the video transmitter. So this is the DJI O3 transmitter, and I've got the antenna here detached. This allows flexibility when you're installing if you want to detach this and get this into the canopy. But I want to discuss really quick how we have the pinouts. So this is the standard cable that it comes with. It looks something very much like this. And what you want to do is you want to take one side for plugging into the air unit, and then take one side and clip it. And then that's going to allow you to solder this to some pins here. And for this one, we want to do a 4-pin. I've got two pins. That's how I'm going to sort this one out for myself. But what we want is the red and black wires from this main cable and the white and gray. The yellow and brown can be folded away or cut or what have you. Those aren't needed. So this is what we have: red, black, gray, and white. So for the first 2-pin connector that I have here, I have black and red, and it goes to black and red naturally. Oh, let's try to get it into focus. There we go. And then for this next one, white and red goes to white and gray. So the white goes to white, and then gray goes to red. And that one is pretty straightforward. So once you have this cable set up for yourself, you want to connect it into the flight controller. I like to plug it into the bottom rung next to the receiver. It's just easy to find. I like to plug in the ground and power first. So that's going to be here. Ground and power. Okay. And then I always, just as a rule of thumb, as a quick flight check, I always keep these reds separated. And that keeps it an easy rule to just plug this in. Okay, so now I have this cable in as red, black, white, red. And that is now plugged into 9 volt and TX RX3. At the very bottom, this is zoom in. Okay. So here's in relation to everything else plugged in. Okay, so let's lay it out how we have in the diagram again. We have our control section here on the bottom, the GPS, and the video transmitter. Once you've gotten to this point, you want to go ahead and power the video transmitter through a battery here. This is going to allow you to power the transmitter. You're not going to be able to power the transmitter through INAV or through this USB cable. Also, quick tip, before you start going through this process with your transmitter, I hope you have activated it, and I won't go through that process, but this is assuming you've activated. You can go ahead and go through this process now. Go ahead and now go into INAV, set up your ports to have this DJI OSD, and go ahead and now plug in your battery to your flight controller and go ahead and start the bind process and make sure you're getting video across. Most importantly, you want to make sure that this 9 volt is getting to the DJI, this is getting power. You should see a light on here. And then once that is powered on and working with your goggles and you're getting video across, you want to start to verify that you're getting your OSD in the goggles. OSD should be working if you have OSD activated in INAV and some kind of OSD screen set up. So at this point, this is the proper time to make sure that all of this video stuff is working between the goggles and the camera. So once you've completed this step, for now, we're just going to assume the video transmitter we talked about real quick and the camera. I want to talk about the pan and tilt gimbal and how that works. So that's here. This is the pan tilt gimbal here. It is 2 servos, very simply, and it's very elegant. I like how it works. I use it for a lot of my aircraft. What we want to do is get the tilt one first, and we're going to plug it into the far left here, into S10. So let me show you guys here. We're here. I'm going to plug this one into S10. And then the pan, which is the bottom servo, is going to plug into S9. So that's here. So there we go. We've got these both in. This is basically the farthest pins on this side here. It's pan tilt. You should always think of them as, 9, 10, pan tilt. So there we go. That's simply how that's connected up. And now we can start to see kind of how this is all working. We already talked about how the gyroscope is already passing the pan tilt channels from the goggles to the remote, to the receiver, to the flight controller. Now we know where these channels are going. It's going to these servos right here.
Well, duh.
So that's simply how all of that works there. So that's how the pan tilt gimbal is connected. So once you have the pan tilt gimbal attached, what you want to do is now go into INAV and start the programming for this. This alone will have its own programming steps. You want just some quick tips. You want to make sure that you don't allow the tilt to go too far or too down, otherwise the gear will slip. Again, these are programming tips. If you would like a programming video, please let me know down below in the comments, and I'd love to make you guys one. But for now, we're just going to say once you have this connected, I assume you know how to do the programming. When you're programming the F-22, I have it shown here in this diagram as this servo controller here in the top right. You get this servo control box, and I'm going to assume that you're setting this up for an F-22. And once you have all of this set up in INAV and you feel comfortable all of this is working at this point from what I've discussed, then you're going to plug it in. You're going to bring all of this stuff into the aircraft, and you're going to try to plug it in and see how it's working with the aircraft side as far as controlling servos. So I like to just plug in, try to get these plugged in order so the cables stay as nice and straight as possible. So we're going to start with S2. We're going to skip, S3. S1 is back over here for the motor. S2 is for a secondary motor. So S3 is the first available servo slot. Let's get a little bit zoomed into that there.
Enhance.
So yep, S3 is going to be our aileron channel, and that's going to be basically the very bottom rung. when you get into your F22 and it's brand new, it's gonna have this device in there and it'll have all these cables sitting out. And this normally what plugs into your receiver. Instead, we're gonna be plugging into the flight controller. So the second one is gonna be elevator. In true reality, it doesn't matter what order these are as long as you program them correctly in INAV, but we're just kind of going through the motions here to show you how this is all connected. Third one is rudder. Next is going to be landing gear. And then flaps. Okay, that's everything plugged in.
Wanna check again?
This is how it kind of looks when it's plugged in. There should be one space there between the pan tilt and all of these servos here. Okay.
Well, okay then.
Another tip about plugging in servos is actually how the motor gets connected. Now, as you see here on servo 1, when you plug in your motor cable to this, realize that there's also a 5-volt power. So you should also be very careful that you're not also sending back power through your ESC. So I have my ESC here. I'm gonna pull it in and I'll show you how I connect it. This ESC here does not have a power pin, so this is okay. This is, the power pin would normally be the red in the middle. So this one can plug directly in, but if your ESC has this power pin, what I recommend is using a short jumper like this and cutting the power cable here. So you're not passing the power pin across. So cut that, plug it in. Okay, I'm gonna show you real quick that you can just cut this cable, no problem. So you wanna cut this red part of the jumper and make sure that we're definitely not passing power to the ESC. And just like that, there we go. We've got just a signal cable, and what this goes is straight into the motor S1 here, white on the towards the bottom here. Okay, and we'll plug it in here. Okay, so that's where the ESC plugs in. And then if you've got a big honkin' 90mm like I do, this is what it looks like. This is a 150 amp Flycolor Dragon. Okay, so now the tricky part about doing calibration at this point is that INAV will not let you arm before it does all the pre-checks and it starts up. So the way to get around this is you need to be connected to the computer with INAV through your USB, and then you're gonna go to the channel or output page and you're gonna turn the channel or output for the motors way up. It's gonna ask you, do you wanna have the motors turned on? Say yes, and then make sure that this is completely way up. Okay, once you've got your flight controller putting out max signal, you can plug in your ESC. Make sure that's good there, and then you know you're connected through USB. You've got max signal coming out through the channel. Your throttle's high, whatever have you. We wanted to make sure that we're getting full output to the ESC. Then you connect your battery. That's how you're going to be able to calibrate. I know, unfortunately, that's a really complicated process to get the calibration done for these, but that has realistically been the only way I've been able to get it on INAV. INAV, if you could please help us out and make that a little bit easier. But as of right now, that is really the only way to do it. So now would be the appropriate time if you want to do a calibration. Again, plug it into INAV, get the throttle to max through the channel page, then you plug in the battery because the controller is already going to be turned on, pushing in full signal. Then you should get the beeps from your ESC to start doing the programming.
And we can hear the beeps!
Assuming that you've made it this far, congratulations. We've connected the servo controller, we connected the ESC, and I showed you how to connect to the battery. Here we are. We finally have, where we started, everything laid out in this web of mess. Hopefully you've learned a bit on how we got here and why we're using specific pieces in order to get this all working. Since you stayed here until the end, I would like to show you a secret piece of electronic that I use in all my FPV plans. This is the ASSAN AG61 Gyro. There we go, into frame here. Now, I think this is absolutely a wonderful piece of equipment to use in all of your more serious planes that you really want to taxi and take off well, because they're expensive planes and you want to make sure that they land and take off well. This is literally going to pay for itself. This is about $25 or something like this. This basically plugs in. This is for 2 inputs, 2 outputs. You plug in your servo into this, your nose gear servo into this, and then attach the gear on the other side. And this basically just works without too much work. I'm going to show you really quick how this is connected into this blue box. So first you want to take the gear in part. This is looking for a gear signal. So what you can do is put this into any of these gear slots here into this blue one. And then when you get to the aircraft, what you want to absolutely make sure is that the plug that was supposed to be here now goes into gear out, which should be this pin here that says gear out. For the next pin is the nose steering. It's on the same side, it's right above the gear. So you can actually plug these two right next to each other. So gear here, and then the next one is nose steering. This one is, oops, be careful. This one is signal on top with ground on bottom. Signal and signal on top. So there it is. This is how we have the ASSAN Gyro connected into the blue box very simply. Now these outputs again go to the nose steering servo and the gear that you took out. So this is again really, really simple.